Hello, grade 12. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutewa Sos Gobela Webet. And without any further ado, let's look at these questions that we have here. Okay, so we have question 2. It says the letters A to F in the table below represent 6 organic compounds. And then we are given all the 6 organic compounds here. And then we know the strategy is, before we can even look at the question, let's try to analyze and see where each of these organic compounds belong. In which homologous series does each and every compound here belong? So looking at this, we can see that these are single bonds between all the carbon atoms. So we know that this is the alkane, right? And then looking at this one, we can see the double bond oxygen is in between the carbon that is in the carbon that is in between other carbon atoms. So this gives you your carbonyl group, which is the ketone homologous series. And then looking at this one here, when you have something like this here, you know that a triple bond forms in between here. So if you were trying to draw this one here, you'd have CH, the first carbon there. We can see that it is bonded to 3 other hydrogen atoms. And then we have the C here. But then you can see that there is no H atom here. So that means in order to have 4 bonds in between the carbon atoms here, you have to have 3 bonds in between here. So this makes it 1, 2, 3, 4. And then also again here, coming to this one, you can see that once again, we don't have any H atom. So that means we need to just bond this once and then like that. So just like this, you can see that now we have created a triple bond there. And then close it off like that. So that's the molecule that we have there, the structural formula. So seeing that, we can see that this is a triple bond, right? This is a triple bond, and then it makes it an alkyne homologous series. Then butyl propanoate, we can see from the name here that this is an ester, because the butyl here is coming from an alcohol, and the propanoate is coming from a carboxylic acid. So this is what is an ester, right? And then let's look at E. From E, we can see that the carbon is bonded to the hydroxyl group. So this means it belongs in the alcohol homologous series. And then looking at F, just by looking at the Br here, bromo, a halogen, we know that now this belongs in the haloalkane homologous series. Right. Now let's start answering the questions. 2.1 says, is compound C saturated or unsaturated? Now, alkyne, we know that alkyne is an unsaturated hydrocarbon. So our answer obviously has to be unsaturated. And then to give a reason for your answer, we say it as what? Multiple bonds, right? There are multiple bonds between carbon atoms. Multiple bonds between its carbon atoms, right? Or you can just straight out tell us that there are triple bonds between the carbon atoms, right? Then 2.2 says, write down the letter that represents each of the following, an ester. So you see now when we have analyzed, it becomes very simple because already we have analyzed D to be an ester. So we're just going to come here, write D. Then 2.2.2, a functional isomer of butanol. Note, a functional isomer of butanol. Butanol is a what? Is an aldehyde. But then we know the functional isomer of an aldehyde according to what? Cake, right, is what? The ketone, right? So do we have a ketone here? Yes, we do have a ketone at B, right? So our solution is just B. Now 2.2.3 says a compound with the general formula CnH2n plus 2. We know that this is a general formula for the alkane. Do we have an alkane here? Yes, we do. It's in A. So you see how easy it becomes when you have first analyzed. Then 2.2.4, a compound used as a reactant in the preparation of compound D. In the preparation of compound D, we want a compound that is used as a reactant. Now we know that a compound D, as we have stated, it is made out of 2 homologous series, which is the alcohol and the carboxylic acid. Now, looking at this, we can see there is no carboxylic acid. So that means the only reactant that is will be used in preparation for compound D is obviously E. Right. And then looking at this, we can see that this is 1, 2, 3, 4. It's butanol. And then here we have butyl. So we know that butyl comes from what? The alcohol, butanol. And propanoate comes from the carboxylic acid, propanoic acid, right? So as you can see, this one is butanol. Okay, 2.3 says write down the structural formula of compound D, right? Write down the structural formula of compound D. So let's come here, 2.3.1. Now, compound D is what? Butyl propanoate. This is how you do it, guys. I want you to look to check carefully how I draw this. This is butyl, indicating that there are 4 carbon atoms. So I will go 1, 2, 3, 4. But then since this is an ester, I know that there is the oxygen that acts as a divisor between the alcohol and the carboxylic acid. So this O here is dividing the alcohol from the carboxylic acid. Now in the carboxylic acid, we have propanoate. So prop tells us that we must have 3 carbon atoms. So I'm going to say 1, 2, 3. Right. Now we know the side with the propanoic acid or the side with the carboxylic acid, meant to say, must have the double bond oxygen. Right? It must remain with the double bond oxygen. And then this one here, we just indicated the hydrogen atoms like that. And then if in here, so you are done. Just like that, you are done. That's all you need to know when it comes to drawing an ester. From the name, this is butyl. So we drew 4 carbon atoms, had our O as our divisor, and then propanoate, that's 3, and then we drew 3 carbon atoms. Then from here, we know that this side is for the carboxylic acid. We indicate the double bond oxygen, and then continue with the H atoms. And then here, we just fill in the H atoms. Then that's it. You have butyl coming from what? Butanol. And then you have propanoate coming from what? Propanoic acid. So that's all you needed to indicate. Then 2.3.2 says name of the functional group of the what? Functional group. Name of the functional group of compound E. Now, compound E is an alcohol, and we know that the functional group of an alcohol, we know it as what? The hydroxyl group. So this is the hydroxyl group. And then 2.3.3 says IUPAC name of the positional isomer of compound E. The positional isomer. What is a positional isomer? Compound with the same molecular formula, but different position of the functional group. So in order to make a positional isomer out of E, we only need to shift the position of the hydroxyl group to carbon number 2 here. And then now what will be the IUPAC name for that positional isomer? Since this one is butanol or butan-1-ol, then that means the positional isomer has to be butan-2-ol, right? So butan-2-ol. That will become the positional isomer of compound E, because now we have shifted the hydroxyl group to the second carbon. Then 2.4 says for compound F, so for compound F, give us the homologous series to which it belongs. Already done that. It's what? Haloalkane, right? So it's very, very crucial to analyze, guys. It makes life easier. Then 2.4.2 says IUPAC name, the IUPAC name of this. So, okay, to write the IUPAC name, allow me to just erase this part here so that I can draw that. So I want to actually first draw it before I can give the IUPAC name so that we are all in the picture. Okay, so we have this here. This is a CH. So the first carbon is bonded to 3 hydrogen atoms. And then this means that we should expand this twice, right? So we have C bonded to 2 hydrogen atoms, and then we're going to expand it twice because we can see the 2 here, right? And then we have the carbon, which should be bonded to a Br, and then also an H. Then we have this carbon here, which should be bonded to 2 hydrogen atoms, and then like that. And then up there, we should have a carbon that is bonded to a Br, and then a hydrogen, and then we have a C bonded to 2 hydrogen atoms like that. So I'm trying to draw it the same way they indicated. Then C and then H bonded to 3 hydrogen atoms. Now, to look for our longest chain, I want you to see this. Have a look at this. The longest chain now will form some kind of a zigzag shape here, right? So this will be our longest chain. All of this will be our longest chain. So do not be confused. All of this will be our longest chain. Now, having to start numbering, if we say 1, 2, 3, 4, we can see that we only see the halogen here, bromine, in the 4th carbon. But let's start numbering from this side. We have 1, 2, 3, and then we can see our bromine halogen here is in the 3rd carbon. So remember, we must start numbering from the side where we see the earliest disturbance, right? So that means we will start numbering from up there. So this is 1, 2, 3, 4, 5, 6, 7, 8, right? And then we can see that our substituents are in the 3rd carbon and the 5th carbon. So this becomes what? The IUPAC name. The IUPAC name now will be what? For 2.4.2, we will say this will be what? 3, and then semicolon 5, and then hyphen dibromo, because we have 2 bromo, two bromo atoms. So it's dibromo, and then the 8 here, remember 8, octopus, octagon. So dibromo octane. So that's dibromo octane. So 3,5-dibromo octane, and that becomes the name of this organic compound there. And that's how you were supposed to tackle this question, guys, for a total of 14 marks. So please press the thumbs up button if you have enjoyed the lesson and then you have found it helpful. And then if you've been watching the videos and haven't subscribed yet, please smash that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.